Hi, today we're looking at Highfield Functional Skills Maths Level 2. This is paper FSQ 210P and we're going to start with the non-calculator section. Okay. Question 1. In a multi-pack of biscuits, there are 12 custard creams, 12 bourbons, 14 shortbread and 15 digestives. What fraction of the biscuits are custard creams? Okay, well, if we want to do it as a fraction, the first thing we need to know is how many biscuits have we got altogether. So we've got 12 custard creams, 12 bourbons, 14 shortbread and 15 digestives. So we're going to add these all up. So 2 plus 2 is 4. Plus 4 is 8, plus 5 is 13, so 3, carry the 1. 1 and 1 is 2, 3, 4, and the 1 carried is 5. So we've got 53 biscuits altogether. So that's going to be my denominator. And we're interested in a fraction that are custard creams. Well, we've got 12 of those, so it's going to be 12 over 53. And we can write that down here in our answer box. Okay. Question 2. Calculate 6 cubed minus 8 divided by 2. Alright, so we're going to think about our BIDMAS rules and what order we do these things in. Well, we haven't got any brackets, but we have got some indices. So this power to the power 3. So we're going to do that first. Well, 6 to the power 3 is the same as 6 times 6 times 6. Well, I know 6 times 6 is 36, but then we've still got to multiply that by 6. So what I'm going to do is I'm going to do this as a column. So we're doing 36 times 6. So 6 times 6 is 36, 6 carry the 3. 6 times 3, or 3 sixes, or 3, 6, 18, plus the 3, 19, 20, 21. So we've got 216. Right, so let's write this. So we've got that this, well, the 6 cubed we've worked out is 216. Then we've still got the minus 8 divided by the 2. Right, so thinking about our BIDMAS rules again, we've got a minus and we've got a division. Well, the B was for in BIDMAS is brackets, I for indices, we've done those. D for division, so we're going to do the division next. Well, 8 divided by 2 is 4. So we keep the 216, take away 4. And now we can just count back 4 from 216 to 215, 214, 213, 212. And there's our answer. Okay, question 3. Calculate the median and the mode of this set of weights. Right, well, the median is the middle number, and the mode is the number that occurs the most. So first thing I'm going to do is I'm going to put them in order from smallest to largest. And before I do that, I'm going to rank them. So what's the smallest? 9. We've got nothing smaller than 9, so that's the smallest. What's the next smallest? And I'll cross that out. And then we've got a 12. So that's next smallest. 27. Yeah, that's going to be our next. Then 28, that'll be 4. What's the next smallest after those? 42. Yeah, that one. Then what have we got? We've got a 51. We've got another 51. And those are bigger. So it doesn't matter which order we do these. We're going to have 6 and 7 for those two. Then we've got 84 would be our 8th. And 90 kilos, 9th. Right, so now I've ranked them. I can write them out in order. So the smallest we had was 9 kilos. Then we had 12. then 27, then 28, then 42, then 6th was 51, 7th was also 51, 8th was 84, and 9th was 90. Right, so for the median, we can start by crossing out the smallest and the largest, and the next smallest and the next largest. And we keep doing this in pairs until we end up with 1 in the middle. So the median equals 42. And we've got we know we've got 9 items here, so we've got an odd number, which means we're only going to get 1 median. If we had an even number, we'd have 2 in the middle, so we'd have to add them together. But an odd number, nice and easy. Or straightforward, I should say. Right, now we need the mode. Okay, so do we have any numbers which occur more than once? Yes, 51. It's the only number that occurs more than once. So the mode is 51. Okay. Right, let's get this here so that we can see. We've got 3 marks for this question as well. Right. So the 3 marks are down here. Question 4. You volunteer for a charity that provides clothing. You are sending a shipment. 1/6 of the items are jackets. 2/5 of the items are trousers. The remainder are tops. What fraction of the items are tops? And then they ask us to show your working out and write the answers or answer in the box below. So what we know is that we've got 1/6 are jackets and 2/5 are trousers and the rest are tops. Now, because these are fractions, the answer is going to add up to 1 because that's 1 whole. Okay, so we've got to work out what this thing is that's going to make all of this equal to 1. Well, we can start by adding these together. Okay, so we'll just think about this bit. Now, to add fractions together, we need to have the denominators the same. Well, at the moment, they're not. So the next thing we look for, well, does one denominator go into the other? No, it doesn't. So we're going to have to rewrite both of these fractions with a common denominator. So we want to think about a number that both 5 and 6 go into. Well, a nice way to do that, not always going to be the most efficient, but a good way to do it is to say, well, if we multiply these numbers together, then both of them must go into that number. So 5 times 6, 6, 12, 18, 24, 30. So we must be able to write both of these fractions as being over 30. And then we say, well, to get from 6 to 30, we multiplied by 5. So that means we're going to have to multiply this by 5 as well. So 1 times 5 is 5. Now looking at this fraction, we've gone from the 5 up to 30. Well, we know we multiplied that by 6, so we also need to multiply the 2 by 6. 2 times 6 is 12. Now our denominators are the same, we can just add the numerator. So we're going to get, the denominator stays as 30, 5 plus 12 is 17. So 17 over 30 plus, we've still got our missing fraction, is equal to 1. Well, if we want to know how many are missing here, well, 17 thirtieths plus something to make 1. Well, 1 would be the same as 30 thirtieths. So if we want to know how many are missing, effectively what we're saying is 30 minus 17. So 0 minus 7 we can't do, so reduces to 2 and we exchange 1 there. So 10 minus 7 is 3, 2 minus 1 is 1, so we've got 13. So what we're saying here is that 17 over 30 plus 13 over 30 equals 30 over 30, which is the same as 1. So the fraction of the items that are tops, well, that's this thing here. This is going to be 13 over 30. Okay, question 5. You are sending another shipment containing 200 pairs of shoes. There is an equal number of men's, women's, boys' and girls' shoes. For each, there are 3 different sizes of shoes: small, medium and large, in the ratio 2 to 2 to 1. So that means for every 2 small shoes, we've got 2 medium and 1 large. You pick 1 pair of shoes out of the shipment at random for a quality check. What is the probability that the pair you pick out is a small girl's pair? Right, okay, so we've got 200 pairs of shoes. Now, what do they tell us? An equal number of men's, women's, boys and girls. So, if we've got 200 altogether and we've got 1, 2, 3, 4 different sort of types, well, 200 divided by 4, or let's do this using a bus stop method. Well, 4 into 2 doesn't go. 4 into 20, 4, 8, 12, 16, 20, that's 5 times. And 4 into 0 is 0. So we've got 50 men's pairs of shoes, 50 women's, 50 boys, and 50 girls. Okay. Now, we are told that we've got this ratio of 2 to 2 to 1 for small, medium and large. So let's draw a little table. So we're going to have, let me get my ruler for this one, try and make it nice and tidy. So we're going to have small, medium, large, and we're going to have our total. So if we just think about one of these sets of 50 for now, we know that they're going to be split in a ratio of 2 small to 2 medium, 1 large. 2 plus 2 plus 1 is 5. So if we only had 5 pairs of shoes, this is how they would be split up. 2 small, 2 medium, 1 large. But actually for each of these groups, we're saying we've got 50 pairs of shoes. So you might be able to see this is 10 times that. Okay, so we can split this up by multiplying this by 10, this by 10, so everything. So it's like saying we've got this ratio, but we've got it 10 times. So instead of 20 small pairs of shoes, instead of 2 pairs of small shoes, we've got 20. Instead of 2 medium, we've got 20. And instead of 1 large pair, we've got 10. Okay, so if we look at that, we are saying that we have got 20 pairs of girls' small shoes. So if we're saying that this is looking at the girls. So we've got 20 pairs of small girls' shoes. Altogether, we know we had 200 pairs of shoes. So this is going to be our probability. Now, we can simplify this. We can cancel a 0, cancel a 0. So we get 2 over 20. And, well, I've got a 2 in both, so I can divide by 2. 2 divided by 2 is 1. 20 divided by 2 is 10. Okay. Now, they haven't said simplify it, so you might be able to get away with writing the probability like this. But when you've got numbers like this, it's nice to be able to simplify it and give your answer as tidily as possible. Okay, so we've got question 6. Let's move this up so we can see at least all of the picture. You are creating an advert for a billboard on the side of a building. Below is a diagram of the space you have available on the building. Okay, so we've got a picture here. We've got the measurements written on it, but we're told the diagram is not to scale. That means we can't just measure things to work things out, okay? But we know we've got 4 metres across the top here, 7.5 metres down, 6 metres all the way across, 3 metres up this section here. Now, if we move it up, what is the total area of the space you have available for the advert? In other words, what's the area of this wall? Show you're working out and write the answer in the box below. Right, so a couple of ways of doing this. We could split the shape up. So I could cut it across here and say we've got a rectangle and we've got a trapezium, and you could do it that way. But I think the way I'm going to do this is say, imagine that we've got one large rectangle. So this corner wasn't chopped off. So we can work out the total area of this, and that's going to be quite nice because we know that the area of a rectangle is the length times the width. So that's going to be 6 times 7.5. And then we can just take off this area because we don't want that. Okay, well, let's start off by working out this 6 times 7.5. So I'm going to ignore the decimal point for now and do 6 times 75. So 6 times 5, or 5 times 6 if you like, 6, 12, 18, 24, 30. So we can put the 0 and carry the 3. And then 6 times 7, 7, 14, 21, 28, 35, 42. Add the 3 is going to make that 45. So we've got 450 in total, but remember there was a decimal point. So we put the decimal point in one place. So we put the decimal point in one place there as well. So we have got 45 meters squared. That's for the whole big wall, okay? So that's including that triangle. Now we want to work out the area of the triangle. And the area of a triangle, hopefully you'll remember, is half times the base times the height. Half, actually, let's leave that as half times, well, the base. Well, let's think of this, let's turn it upside down. So instead of thinking it as that as the top, we're going to think of this triangle as being this way round. The area is going to be the same. So the base is going to be this measurement here. Well, we know that the full measurement of the wall is 6 meters and this section is 4 meters. So this here is going to be 6 minus 4, which is 2 meters. Now that's for the base. So it's going to be a half times 2. And the height, so the height, that measurement there, well, we know all of this is 7.5 and this bit is 3. So we want 7.5 or 7.5 minus 3. That's going to leave us with 4.5. So we've got the height as 4.5. Right, now you can multiply these in any order, but I've got a half and I've got 2. Well, I know that half of 2 is just 1. So we end up with 1 times 4.5, which is just 4.5 metres squared. So for the total area, we've got 45, which was this bit here for the whole thing. We want to take away the triangle, which is 4.5. So I'm lining this up and I'm keeping the decimal point this time. Okay. Now, we've got nothing to take the 0.5 away from at the moment, so I'm going to put a 0.0. So we've got something that we can use. Right, so now we say 0 take away 5. Well, we can't do that. But what we can do is reduce that to 4 and pass 1 over there. So we've now got 10 take away 5 is 5. Keep the decimal point lined up. Now we've got 4 minus 4 is 0. And 4 take away nothing is still 4. So the total area of the space we have available for the advert is 40.5 metres squared. Okay. The company selling the billboard is offering a discount. The regular price of the billboard is £620 per month. They are offering a discount of 12.5% from the regular price. What is the new monthly cost? Right, now some of you may spot that 12.5% is the same as 1/8. And you could divide that by 8. Now, I don't expect everyone to spot that. If you do, well done. And that'll probably be a nice sort of shortcut way to do it. Instead, what we can do is the 12.5%. We can think of that as 12.5%. Let's break it down into easier to manage chunks. Well, we know how to work out 10%. That's quite nice. So we can think of that as 10%. And then we have 2.5% left. Well, let's think 1%. Again, if we can work out 10%, we can work out 1%. And another 1%, so that's 10, 11, 12. And then we want 0.5%. Okay, so you'll see why we're doing this. So now we can say, well, 10%, well, I know for 10%, I just cross the 0 off. So that's going to be £62. 1%, well, that's like dividing by 10 again. So we haven't got a 0 to knock off anymore, down to 62, but instead we're going to move the decimal point over. So 1% is going to be 6.2, and because it's pounds, it's going to be £6.20. Well, we've got another 1%, so it's going to be the same again. And 0.5 is 0.5%, so we want half of 1. Well, half of 1%. So if we know 1% is £6.20, we want £6.20 divided by 2. So let's use the bus stop method again. So 2 goes into 6 3 times, put decimal point. 2 goes into 2 once, 2 into 0, doesn't go. So 0.5% is going to be £3.10. Right, so now we've got our different parts here. So we just need to add these all up. So let's shift this up. So we've got £62, £6.20, another £6.20, and £3.10. And there's other ways that you could split this up. I've just done it in a nice way here. You could work out 5% and do half of 5% for 2.5. But I think this is a nice way to explain. So we want to add these together. Now, first thing, the £62, I'm going to put in zeros. So we've got something here to add to everything. All the zeros are 0. 0 and 2 and 2 and 1 is 5. 2 and 6 is 8. And 6 is 14. And 3 is 17. 6 plus 1 is 7. Okay, so we've got £72.50. Now this is the discount. So this is how much off the price we can take. So the original price was £620, and we're going to reduce it by £77.50. So as we did before, I'm going to put zeros up here, so we've got something to take our 50 away from. 0 minus 0 is still 0. 0 minus 5 can't do, so I need to take 1. I haven't got 1 to borrow from here, so instead I'm going to go to the 2, reduce that to 1, and add a 1 here to 10. Now we can reduce the 10 to 9 and pass 1 over here. So we've got 10 minus 5 is 5. 9 minus 7 is 2. 1 minus 7 we can't do, but we can, because we've got nothing else, we can think of it as 61. Actually, no, we will do that. We'll reduce the 6 to a 5 and pass 1 over. So we've now got 11 minus 7, which is 4. 5 minus nothing is still 5. So we get a final answer of £542.50. So that's £620 with a 12.5% discount. And that's the end of the non-calculator paper. So now we're on to the calculator section. Alright, let's see. We're not going to be able to see this all in one go, but I can move it up. 5 corners of a hexagon are drawn on the grid below. What are the coordinates of the 6th corner? Well, they haven't said it, but I'm assuming they want a regular hexagon, because I could put a cross anywhere and it would still be a hexagon. But let's not be pedantic and let's assume, let's say they want a regular hexagon. So let's connect these dots and it'll make it easier for us to see where an extra point might go. Well, we'll follow up from here. So we're going to want something there. Okay, so what are the coordinates? Well, they haven't written them in, but that would be -1, that would be -2. And the y coordinate, well, it's just up 1. So it's going to be -2, 1. And we can write that in there. Okay. Question 2. The diagram below shows an isosceles triangle with 2 equal sides and 2 equal angles as marked. Well, as you know, isosceles triangle means it's got 2 equal sides and 2 equal angles. So they're telling us that as well, which is nice of them. Calculate the value of angle Z down here. Show you're working out and write the answer in the box below. Right, well, we can use our calculator now. So we're going to use a couple of rules. The first rule we're going to use is that the angles in a triangle add up to 180 degrees. So if we take away this angle here, we're going to have the sum of these 2 angles left. So let's do 180 minus 23, and we've got 157 degrees. Now, because both of these angles are the same, we can divide this by 2. And we get 78.5 degrees. Okay, actually I'll put that in here. Alright, now we're on to question 3. The tallest point in England is 3,209 feet above sea level. I'm going to put a comma in there. Okay. The lowest point in England is minus 9.8 feet below sea level. What is the difference between the tallest and lowest points in England? So they're asking us to work out the range, really. Well, if we want the difference between them, we take the biggest, 3,209, and take away the smallest. Well, note the smallest is actually minus 9.8. So we've got two minuses here, and hopefully you remember that when you've got two minuses together, it becomes a plus. So we've got 3209 plus 9.8, and we get 3,218.8, and that's feet. And we can put that in there. Now, if you're struggling a bit with the minus, think of this as something like this. This is our 0. Okay, so we've got all the way up here, goes up to 3,209. But then we've also got this little bit down here, which is taking us down to minus 9.8. So if we want the difference between them, we've got to add everything that's above 0 to everything that's below 0, which is how we get our answer. Okay, question 4. Which of the following fractions is equivalent to 40%? Okay, well, what I'm going to do first of all is I'm going to say, well, instead of fractions, I'm going to work with decimals. And I'm going to say, well, 40% is the same as 40 over 100, which is equal to 0.4. So I can just type all of these into my calculator, 40 divided by 1,000, and see which of them give me 0.4. Well, this is 0.04, so it's not that one. 120 divided by 300, that's 0.4, so that's looking promising, but let's check the others. 4 divided by 20, that's 0.2, so that's no good. And 100 divided by 40, well, that's top heavy, so it's going to be more than 1. 2.5, so that's no good. So the answer we want is 120 divided by 300. Okay, question 5. A company has a budget of £810,530 for a new project. The first phase of the project costs £237,219.62. How much of the budget does the company have left after the first phase? Show your working out and write the answer in the box below. So remember, we had 810,000, so 810,530 pounds. So that's what we're starting with. So basically we want, from that we want to take away the first phase. And again, remember, you can do this on your calculator. I'm sure you can work it out without, but we don't want to waste time. I'm going to be efficient in the exam. And we get 573,310. 38. So £573,310 and 38 pence. Again, we can write that in here. Okay, question 6. Put the following decimals in order from lowest to highest. Right, well, we've got 25, 26, 25, 25. Well, this is quite clearly the biggest. So I'm going to write that at the end. For the others, they all look very similar. So what I'm going to do is I'm actually going to write them one on top of the other, lining up my tens, my units and decimal places. Okay, so if we want so with the 25s are all the same, so I can kind of cover that up really. And all I'm comparing is 642, 462 and 246. Well, this is quite clearly the smallest, then this one, then this one. So, writing it out in full, we get 25.246. Then we have the 25.462. Then we have the 25.642 and the 26.524 as the largest. Question 7. Convert 17 pints into litres. Now they've given us the conversion. They've said that 5 pints is equal to 2.84 litres. Right, so how's that going to help us? Well, what we can do is say, well, if that's 5 pints, what would 1 pint be? So let's divide this by 5. So that would tell us that 1 pint is going to be, well, let's write it out. It's going to be 2.84 divided by 5. Which is 0.568 of a litre, or litres. Now we want 17 of them, 17 pints. So we're going to multiply that by 17. So I've already got it in my calculator. Just times it by 17. And we get 9.656. And that is now in litres, which we can put in here. Right, question 8. Which of the following values is the largest? Right, so 850 divided by 1000, 2 and 1/9, 7 over 3, or 2 and 7 over 550. We had something similar earlier. Well, I just turned everything into decimals, so I'm going to do the same again. So 850 divided by 1000, well, that's 0.85. 2 and 1/9, well, let me do the 1/9 bit first. 1 divided by 9, and then just add on the 2. So we've got 2.111 recurring, just to show that carries on. 7 divided by 3. Well, that's 2.333 recurring. And for the last bit, again, let's deal with the fraction first. So we've got 7 divided by 550. And then add on, what was it, 2. So we've got 2.012, but that's a 7, so I'm going to round that to 3 decimal places. Which is the largest? Well, it's definitely not this first one, because this is less than 1, so it's not that. So we've got 2.1, 2.3, 2.0, so it's going to be this one here. But the format they gave it was actually a 7 over 3. Okay, question 9. Identify the types of correlation in the following scatter graphs. Okay, well, we've got one here. Well, we don't have to, but I think it's going to help if we draw a line of best fit. So that's a line that goes through the data, following the overall pattern, with roughly the same number of points above as below. So we've got this line which is going down. So as our x gets bigger, our y gets smaller, and we describe that as a negative correlation. Now we've got graph B as well. So let's draw a line of best fit, because this sort of, if you just look at it, it looks fairly flat. But if we draw a line of best fit through there, you'll see actually that's going up. So if, as our x increases, the x-axis, our y-axis goes up as well. It's getting bigger. So this one is a positive correlation. So getting bigger and getting bigger, so going up, positive, going to the right, but sloping down is a negative correlation. Okay. Question 10. You work as a lorry driver for Highfield Transport. You receive your monthly wage slip. And here it is. So we've got salary, 1 unit, so 1 salary. We've got a rate of 1843.71, and the amount is 1843.71. That's the money. We've got space for tax, national insurance, pension, and our net pay. So the net pay after all of the expenses or deductions have come off. Your annual salary is £22,124.48. You have a tax-free allowance of £12,500. You need to deduct PAYE tax, pay-as-you-earn tax, which is this here, and national insurance on the salary that you earn after this allowance. PAYE tax is 18.62% on your earnings after your tax-free allowance. National insurance is 15.7% on your earnings after your tax-free allowance. Your pension is 3% of your total monthly salary. Oh, let's move this up here. Before any tax deductions. And then it asks us to complete your monthly wage slip above, calculating the PAYE tax, national insurance, pension, and net pay. So in other words, these 4 numbers here. Right, so how shall we start this? Well, we're told that PAYE... Well, we've got a tax-free allowance, first of all, haven't we? So what that means is we've got £22,124.48 a year, but we can take off £12,500 to find out how much we pay tax on. Okay. So you can earn this money and not pay any tax at all. So we can do the 22,124.48, take off the 12,500, and we get £9,624.48. Okay, now that's for the whole year. So we want to know how much money do they have to pay tax on per month. Okay, so if we divide this by 12, we will get, and I've still got that in my calculator, so we can just do divided by 12, and we get £802.04. So that's not the tax that we pay, but that's the amount of salary that we pay tax on. So we've got to pay 18.62% of this £802. So 18.62 divided by 100, because it's a percent at the moment, multiply it by 802.04. So, or we can do it in reverse. We've already got the answer in, so we multiply it by 18.62 and then divide it by 100. We're talking about money here, so we're going to round to 2 decimal places. So 149.33, but this is more than 5, so it's going to be 0.34. So £149.34. So we can put that straight in here. Okay. Now, let's work out the national insurance next. This is 15.7% on your earnings after your tax-free allowance. So it's going to be a very similar calculation to this one above, but with 15.7% instead. So 15.7 divided by 100 and multiply that by £802.04. And we get £125.92. And we can put that up there. Okay, so you can see with all of this, because this is a pay slip, it's monthly, so we needed to start off with annual salaries to take off the allowance, but then we've gone straight down to working everything out on a monthly basis. So we also need to work out the pension, and we're told that your pension is 3% of your total monthly salary before any tax deductions. So 3%, so 3 out of 100. So before any deductions, that's basically this amount. That's just our annual salary divided by 12. Okay, so let's work out that. So 3 divided by 100, and then multiply that by £1,843.71, was it? Yeah. 55.31. Okay, so that can go up here. Right. So the net pay is this figure, take away all of these. So I could take one off at a time. What I'm going to do is I'm going to add them all up and then take them off in one go. So 149.34. And what you might find on your pay slips is you might find usually you'd have a total deductions line as well. So our total deductions are going to be £330.57, and we want to take that away from this amount here. So let's put that in my calculator to memory. So £1,843.71, take away memory recall, and that leaves us with £1,513.14. Okay. So quite tricky, these questions, but really handy. So especially if you've got pay slips of your own, you can do checks and make sure you know how things are being calculated and that you're not paying too much money away. Right. Question 11. You are about to set off on a delivery. You are looking at the possible routes and how long each will take. So route A, 105 minutes. This is the regular journey time. Route B is 70 minutes and route C is 60 minutes. But then we're told today's traffic forecast for warehouse to delivery point, only 7/9 of the regular journey time. And then from the delivery point back to the warehouse, only 8/9 of regular journey time. So this is saying it's going to be quicker than usual. Okay. For route B, add 2/6 to regular journey time. Okay, so it's going to take longer. And on the way back from the delivery point to the warehouse, add 1/5 to regular journey time. For route C, we're going to add 42% to the regular journey time. And on the way back, we're going to add 28% to the regular journey time. So, what's the question? You will start at your warehouse, go to the delivery point, then return to the warehouse. Considering the traffic forecast for the journey to and from the delivery point, Which route will be the fastest? Show your working out and write the answer in the box below. Right, so for each of these, we want to work out what the adjusted journey times are. So for route A, it's 105 minutes, but it's only going to take 7/9 of that. So we can say 7 divided by 9, multiplied by 105 minutes, and we get 81, I'll round it to one decimal place, 81.7 minutes. Okay. And then on the way back, we want 8/9 of this. So in fact, I'll do the 105 first, times 8 divided by 9, and we get 93.3 minutes. So if we want the total time, let's put a total down here. So we had 81.7, add 93.3, and we get 175 minutes. Normally I'd say use the exact answers, not rounding them, but I'm not expecting our answers to be so close that the rounding matters. So let's see if this is okay for now. So route B, add 2/6 to the regular journey time. Well, what are 2/6? So 2 divided by, actually let's do, let's put the number in first. So 70 times 2 divided by 6. So 23.3 minutes extra. So we're adding that on. So add that to the 70. So we're going to get 93.3 minutes. Oh, sorry, I wrote those on top. I'm writing this underneath, but hopefully it's still clear enough. And add 1/5 to the regular journey time. So we've got 70 minutes again, times 1 divided by 5. That's 14 minutes extra. Add on the original 70, and we get 84 minutes. So if we add them together, we get a total of 177.3 minutes. Now we're on to route C. Add 42% to the regular time. Well, 42% would be 42 divided by 100. Multiply that by 60, 25.2, and that's adding on, so then we add on the 60 itself, which gives us 85.2 minutes. And on the way back, we're told add 28%, so 28 divided by 100 is 0.28. Add on the original 60. Oh, what did I do? I did something wrong. 28 divided by 100 was 0.28. We multiply that by the 60, so it's an extra 16.8 minutes. Add that on to the 60, so we get 76.8 minutes. Add these together, so 76.8 plus 85.2, and we get a total time of 162 minutes. Okay, considering the traffic forecast for the journey to and from the delivery point, which route will be the fastest? Well, this is the smallest, so it's going to be route C. Okay. However, so that is the correct answer. I don't really like this question because it assumes that you have to go out and come back the same way. If you wanted to save time, well then you'd use route A on the way out because it's the shortest time, 81.7, and then you'd use route C on the way back. So actually the shortest time would be even shorter than that, but they don't seem to like that in the model answer. I don't know why. I think they're just trying to keep it simple. So if you did do that, well done. Unfortunately, they don't like that. So they're looking for the overall route. So you're doing the same route there and back. Hope that makes sense. Right, question 12. You are looking at the journey times of your deliveries over 2 months. This table shows the number of journeys you made each month and their duration. So we've got journey time of 0 to 2 hours. We did 7 journeys between 0 and 2 hours in April and 13 in May. We did 4 journeys in April that were between 2 and 4 hours, and we did 10 journeys in May between 2 and 4, and so on. Use the data to estimate the difference in the mean journey time between the two groups. Right, so we're going to work out a mean for April and a mean for May and see which is and then work out the difference. Now the estimate bit, usually that means we've got to do some sort of rounding, but the estimating we're doing here is that our journey times are in ranges. So we don't know if all of these 7 journeys in April were 5 minutes or 2 hours or some in the middle, some longer. So what we're going to do is say, well, the only thing we can reasonably assume is that the journey time was right in the middle. So between 0 and 2 is 1. If we want to check that or use our calculator for that, well then all we'd be doing is we'd say 0 plus 2 and then divide it by 2, which gives us 1. Okay, so we can do the same here. 2 plus 4 is 6, divided by 2 is 3. Or we can say what's halfway between 2 and 4. Well, that's 3. So what we're working out here is the midpoint of the range. So halfway between 4 and 6 is going to be 5. Halfway between 6 and 8 is 7. And halfway between 8 and 10 is 9. Right, we're looking at mean journey time. Well, the mean is the total divided by the frequency, or how many. So the total, so we want to know what the total hours were. And we want to do that for April, and then separately we'll do that for May. So we had 7 journeys that were 1 hour long. So 1 times 7 is 7. We had 4 journeys that were 3 hours long. So 3 times 4, that's going to be 12 hours. 11 journeys were 5 hours long. So 11 times 5 is 55. And you can use a calculator for some of these if you prefer. 5 journeys were 7 hours long. 5 sevens, 35. And 6 journeys which were 9 hours long. 6 nines, 54. So we can add these up to find the total number of hours in April. So 7 plus 12 plus 55 plus 35 plus 54 gives us 163 hours. Now we're going to do something similar for May. So I'm going to copy my midpoints across, because the midpoint's going to be the same, because we're looking at the same ranges. So we're going to have 1, 3, 5, 7, 9. And again, we're going to be multiplying these together. 1 times 13 is 13. 3 times 10, so it's 10 journeys which were 3 hours each, are 30 hours altogether. 5 times 7 is 35. 3 journeys at 7 hours each is 21. And 1 journey at 9 hours, that's 9. So let's add all of these up together now to find the total hours. 13 plus 30 plus 35 plus 21 plus 9 gives us 108 hours. Right, but we're interested in the mean journey time. So we want to know how many journeys there were, because that's important. So in April, how many journeys did we have? Well, we had 7 plus 4 plus 11 plus 5 plus 6. So we had 33 journeys. So the mean for April let's move this up a bit, is going to be 163 hours divided by 33 journeys. And that is 4.94, should we say? 4.94 hours. Now, the mean for May is going to be 108 hours divided by, and now we're going to add up the number of journeys here. So we've got 13 plus 10 plus 7 plus 3 plus 1. So 34 journeys. And 108 divided by 34. We've got 3.17, but this is more than 5, so we're going to make that 3.18 hours. Right. Now the actual question, use the data to estimate the difference in the mean journey time. Well, we've got our two mean journey times. They want the difference. So if you want the difference, you take the biggest and you subtract the smallest. So 4.94 minus 3.18, and we get 1.76 hours. So a lot going on there, 7 marks. You need to use the midpoints, and really we're repeating the same process for April and May. See here. Question 13. You make several craft items which you sell online. One of the items you make is a wooden photo frame. The photo frame is made of a backboard measuring 40 centimetres by 25 centimetres, a top and bottom piece measuring 45 centimetres by 5 centimetres each, 2 side pieces measuring 20 centimetres by 5 centimetres each. Make a plan of the pieces of wood that will make up the frame. Use the graph paper on the next page to draw the 5 pieces of wood. Use a scale of 1 to 5. Show any workings in the box below. Right, so let's try and do a, before we do it accurately, let's try and do a sketch. So we've got this backboard, and we're told it's 40 centimetres by 25 centimetres. Then we've got a top and a bottom piece which are 45 centimetres by 5 centimetres. So we've got a bit up here that's a bit longer than the base, so this is 45 centimetres, and that's 5 centimetres. And we've got a top and bottom piece, so we've got the same thing down here. So 45 centimetres, 5 centimetres. Then we've got 2 side pieces measuring 20 centimetres by 5 centimetres. So these are not quite as long as that. So 20 centimetres and 5 centimetres. 2 side pieces, so we can have another one over here, 20 centimetres, 5 centimetres. Okay, so that's just a bit of a sketch for us. But what they want is to make a plan of the pieces of wood. So they want this accurately, and they want to use a scale of 1 to 5. So that means 1 centimetre on the, which way is it? 1 centimetre on in real, 1. So 1 centimetre in real life will be 5 centimetres on here. No, other way around. 1 centimetre, 5 centimetres in real life would only be 1 centimetre on here. Right, I think I'm getting it the right way around. Yeah, that's got to be right, hasn't it? Because 45 centimetres, we're not going to draw something that big, we need to make it smaller. So we're going to need to divide all of our measurements by 5. Okay. So if we think of 45 divided by 5, it's going to be 9. Oh, sorry, 45 divided by 5 is 9. 5 divided by 5 is going to be 1. 20 divided by 5 is going to be 4. Again, you can use your calculator for this. 45 divided by 5 is going to be 9 again. 25 divided by 5 is going to be 5. And the 40 centimetres divided by 5 is going to be 8. Okay, so a little bit of scribbling there, but what we'll do now is the accurate drawing. Okay, right, so each of these, now I think it depends on how this is printed out, but it should be, yeah, each of these squares, each one of these is 1 centimetre. So if we have a look back at our sketch, let's start with the backboard. So we said that it was 40 across, but divided by 5, that was going to be 8 centimetres by 5 centimetres. Okay, now we can actually count them out. So let's say we're going to start here. 1, 2, 3, 4, 5, 6, 7, 8. And go down 5. 1, 2, 3, 4, 5. So this corner is going to be down here. And this was our backboard. Right, then what did we have next? Well, we had our top and bottom pieces, which we'd said were going to be, once we'd used the scale, once I'd worked out which way round it was, but we're going to have 9 centimetres long and 1 centimetre down. So let's make it here. So 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this was the top. We had the bottom that was the same, so we can draw another one below it. And you can see this question can take quite a bit of time because you've got to be careful, keep measuring and referring back to the previous diagram. So it might be you want to leave questions like this to the end, it's up to you. Just to make sure you don't run out or spend too much time on it. And the side pieces were 20 centimetres long, which we said that equates to 4 centimetres once you apply the scale. And 5 centimetres is the same as 1 centimetre across. So we want side pieces 4 by 1. I'm going to do them up here so that they fit on 1, 2, 3, 4. So this is a side, so let's call it side 1, and we're going to have the same again and we can call this side 2. Okay, So quite a bit of work. We've got 5 marks there. I say it's more about the time. It can take quite a bit of time to do these things, but when it's done, hopefully you can see it and you can do your measurements and check it and be happy with it. Okay, question 14. You send the photo frames in boxes which you cover in paper. So we've got 20 inches long, 12 inches across and 6 inches high. And we're told that 1 inch equals 2.54 centimetres. You need to calculate the surface area of the boxes in centimetres to find out how much paper you need to cover each box. As you need to include additional paper for the flaps, you use the following formula to calculate the total amount of paper required per box. So we've got S times 0.5 pi equals T, where S is the total surface area, and T is the total amount of paper required, and pi, we're told, is 3.14. What is the total surface area of the paper required per box? Give your answer in centimetres squared. Right, so we've got to apply this formula. Before we can work out what T is, we need to know what the total surface area is. Right, so, and before we start with any of this, we want our answers to be in centimetres. So let's get rid of the inches. Let's turn everything into centimetres to start with, and then we don't have to think about the inches anymore. So if 1 inch is 2.54 centimetres, well, 20 inches, you're going to multiply it by 2.54. In fact, all of these we're going to multiply by 2.54. So this makes this 50.8 centimetres. 12 times 2.54 gives us 30.48 centimetres. And 6 times 2.54 gives us 15.24 centimetres. Okay, all right, we've got some decimals in it now, but it's just simpler to not have to worry about inches anymore. So if you think about the surface area, well, we've got, what should we work on first? Let's think of the ends. Okay, so I'm going to call these, it's an end, it's a side, and it's a top. Or bottom, because the top and bottom are going to be the same. So think about the ends. Right. Well, the area of one end is going to be the length times the width, or times the height. Basically one dimension times the other. Okay, but we've got two ends. We've got this end and we've got this end over here that we can't see. So we're going to multiply all that by 2. So we can call that ends. So let's work these out. So 30.48 times 15.24 and then times 2 because we've got 2 of them, and we've got 929 point, I'll do 2 decimal places, 0.03, and that's centimetres squared. Okay, now what should we do next? Let's do the sides. Actually, I'm going to underline that because that's important. So for the sides, well, the length is 50.8. The height is this height here, which is 15.24. And again, we've got 2 sides. So we multiply the whole thing by 2. So if we do that, we get 50.8 times 15.24 times 2. And we get 1,548. We'll stick with 2 decimal places, 0.38 centimetres squared. And we'll underline that again. So we've got the two ends, we've got the two sides. Now we want the, I'll do it here, the top and bottom. Well, the length of the top is the same as the length of the sides. So 50.8. Then we want this measurement here, which is the 30.48. And again, there's two of them because we've got a top and a bottom. So 50.8 times 30.48 times 2. And we've got 3096.76, but this is more than 5, so we're going to make it 0.77. Right, so we've got these three measurements here. Let's just see, that all looks good to me. So now we want to know what the total surface area. So this total surface area, well, it's going to be all of those numbers added together. So it's going to be the 929.03 plus the 1548.38 plus the 3096.77. 929.03 plus 1548.38 plus 3096.77, and we get 5574.18 centimetres squared. Right, now we actually want to work out what T is. So we need S, which we've got, times 0.5. 0.5 pi, so that's going to be times 3.14. So, still got this in my calculator. Multiply it by 0.5, multiply it by 3.14, and we get 8,751.46 centimetres squared. Okay, now, oh, it's down there. I did a little bit of rounding, but we're not going to lose much accuracy there. If you use the exact numbers and kept them in your calculator memory or wrote them all down, absolutely fine. Yeah, there's nothing wrong with that at all. But this will still get you your 4 marks. Right, quite a big question. Lots of number crunching. Question 15. You also make candles which you sell on your online craft shop. You sell candles for £6.75p each and photo frames for £8.99 each. 58% of the selling price is profit for each item. Last month you sold 46 candles and 31 photo frames. You estimate it takes 30 minutes to make each candle and 1.5 hours to make each photo frame. Calculate how much profit you earn per hour. Right, per hour. So let's think about this. So what we want to do is work out what the total profit was and then divide it by how many hours it took to make them all. So if we start with the candles, they were £6.75p each and we made 46 of them. Okay. So that's £310.50p. But only 58%. So which point do we work out the profit? Let's do that here. So only 58% of that is profit. So 58 out of 100 times £310.50 times 58 over 100, and we get £180 and 9p. Okay, that's profit. Now photo frames. So they were £8.99 each, and we sold 31 of them. Which is £278.69. Now, if you want to work out the profit of each item individually first and then multiply it up, that's absolutely fine. You should get the same answer. So multiply this by 58 out of 100. That's going to be 279.169, and we get £161.64p profit. Okay, so our total profit is going to be 180.09 plus 161.64, which is £341.73p. Now we've got to consider the time. How long did it all take? Well, it was 30 minutes to make each candle. Well, 30 minutes, that's half an hour, or 0.5 hours. So if we've got 46 candles, so let's do time. 46 candles, half an hour each, so that's times 0.5. That's 23 hours. And then with the photo frames, we had 31 of them, and they take 1.5 hours each. So 31 times 1.5 is 46.5 hours. So in total, if we add the 23 and the 46.5, we've got 69.5 hours. Okay, so we had £341.73 profit. We divide that by the number of hours. So put that in the calculator memory. So 341.73 divided by memory, and we get £4.90. We want two decimal places, so we're going to round that up. So £4.92 per hour. Okay, not bad. Seems reasonable. Sounds like a lot of work, but if you enjoy what you're doing, that's fine. So on to the final question now. Question 16. These are your figures for selling candles and photo frames last year. So in January we had sales of £212, February sales of £194, and so on. What is the percentage increase in your mean monthly profit from the first 6 months to the mean monthly profit from the second 6 months? Show your working out and write the answer in the box below. Right, so we've got first 6 months, second 6 months. We want the mean monthly profit and then work out the percentage increase. So for the mean, remember we said mean equals the total divided by the frequency. So we want to add all of these up. So 212 plus 194 plus 245 plus 302 plus 275 plus 242. So we've got a total of 1,470. Okay. Now we've got... Actually, yeah, we'll leave that for now. We'll do the mean bit afterwards. We'll just get these totals. And then for the second 6 months, we've got 298 plus 275 plus 306 plus 314 plus 339 plus 364. So £1,896. Okay, so mean for first 6 months is going to be 1,470 divided by 6. So 1,470 divided by 6, and we get £245. Then we want the mean for the second 6 months, and that's going to be 1,896 divided by 6. And we've got £316. Now, we want the percentage increase in your monthly profit. Well, what's the actual increase? Well, the actual increase is 316 minus 245. Which is £71. So the percentage increase is going to be the actual increase divided by the original amount, which was 245, and then multiplied by 100 to turn that into a percentage. So 71 divided by 245 times 100, 28.97. We're going to round that up. So we're going to get 28.98%. And that's the end of the paper. So quite a heavy going paper. Definitely not an easy one to do. So well done if you managed to get all the way through that. Please do like, add any comments, subscribe to the channel so you get updated as I add more videos. And I look forward to seeing you again next time. Thanks.